this about the Siemens software lah. Then they have other like if like PLC also they have a logo, Siemens logo, all that.
Okay.
Okay. Yeah. So, but if you see, yeah, all these three PLC lah, okay, the programming way is same. Okay, programming way is same. Only different is the software that they lay out.
Like the TIA portal, I believe you can see the hardware as well, right? I mean like you can download the program and turn it to hardware, if I'm not mistaken, right?
What do you mean? I don't understand. The
Uh,
TI portal, okay.
for the TIA portal, you can like download the program. Like you don't have any program. Like you want to
Okay.
see how's the hardware configuration for for a PLC
Yeah.
for the system.
Yeah.
You can download from the CPU,
Hmm.
and then the hardware configuration. Oh, but that one you can see from the Simatic Manager as well, right?
Yeah.
Yeah. Okay.
Okay. I understand. So you mean the configuration, right?
Yeah.
Yeah. From Simatic Manager also you can see.
Okay.
All right. Okay. So since I have this hardware, okay. So later when downloading, uploading anything, you can use my laptop lah. I will give you the access. Then you can use my PC. Okay.
Oh, okay.
Then if exercise anything, then you can use your PC. Okay.
Okay.
Because you don't have the hardware, right?
Yeah, I don't have the hardware with me.
Yes. Okay. Right. Then next, okay, you know about this PLC where they are using. Okay. So now mostly all industries are using PLC lah. Now mostly all automated, right?
Yep.
Okay. So all industry now start using PLCs. Okay. So this about the PLC, the hardware side. Okay. So any PLC, this one is for general. Okay. For general, any PLC. Okay. So they call it is a CPU, right? Okay. The CPU, you have a memory. Okay. All right.
Okay.
Then I connect input module and output module. Then I connect all the inputs, okay, like digital inputs, like analog inputs, all that. Then I use the software. Okay, I use the software and download. Then when there is inputs on, it will process in the CPU, then on my output.
Okay.
All right. Then so here I have some examples lah. Input, analog input, digital input, analog output, digital output, all that. Okay. All right. Okay. So this is what exactly I have here lah. Okay. Right. So this is what exactly I have here. You can see I have a CPU and two I/O cards. Okay. So just want to go through about the CPUs here. Okay. So you know this is the part number lah.
Yeah.
Okay. This one you know, right? The part number, everything. Okay. Okay. What I want to show you clearly is here. Okay. Here on this side, on the hardware side, you can see I have a few LED here. Okay, like SF is a system fault. Yeah. Okay, then the bus fault. Okay, then DC 5 volt. Okay, pause, run, and stop. Okay.
Okay.
Then here is the memory card.
Okay.
Okay. So system fault, when I have a fault on the PLC, the CPU, I have a system fault.
Okay.
Okay. All right. Bus fault. Okay. Bus fault 1 and 2. I have two bus fault because I have two communication. Okay.
Okay.
Okay. Because number one is the X1 is the this port lah. Okay. This
Okay.
port that is the MPI or DP.
Okay.
Okay. MPI, the MPI cable, right? Okay.
Yep.
Then DP is the Profibus.
Yep. Okay.
Okay. All right. Then X2 is the LAN lah. LAN, Siemens they call Profinet.
Okay.
All right. Okay. Then the DC 5 volt is for the memory card.
Okay.
Okay. Then force. Force is if I force any input inside, I can see the lamp.
Okay.
The force lamp. Then the run and stop lamp lah.
Okay.
Okay. Then I have here run, stop. This one is the memory reset. Okay.
Okay.
Alright. So this is about the hardware we have. Okay. Then this for the communication lah. Okay. We have a PC adapter.
One question.
Yes.
Never mind lah. Never mind. I want to ask about system fault, but maybe later.
Maybe later lah. System fault lah.
Later. Yeah.
Okay. No problem.
Okay. Alright.
So any question now you can ask me, no problem. Okay, because it's just one-to-one, right?
Alright. So I want to ask regarding
Yeah.
the system fault.
Hmm.
You said it occurs when there's a fault in the CPU. That includes the programming, right?
Yes.
Okay. So let's say if there's a system fault and then there's something that's been programmed
Yeah.
to the output module, and then
Okay.
let's just say it's a sensor, and then that sensor is not connected. Will it
Yeah.
give a system fault as well?
No.
No?
No.
Okay.
So what you mean is, okay, let's say I have output connected. So this is the input here. Let's say one output connected. Let's say this cable is broken.
Okay.
Okay. So do you mean this cable is broken? Will it give a system fault, right? That's your question, right?
Yes.
No.
No. Okay.
System fault will give. Okay, there's a few faults lah. Okay, number one is the communication.
Okay.
If there's a bus fault, then it will give a system fault.
Okay.
Okay, that is number one. Number two, for example, is if I already configure this two cards here, okay, two slot, and suddenly I take out one slot, or one slot is broken, this module, right?
Okay.
Then it will give a system fault because
I see.
the configuration is not complete.
Okay, I got it.
Then there are few system faults lah. Later we will see.
Okay.
Okay.
All right.
So, okay, good, because whenever you give me what you want to know, right, then it's easy to me to teach you. Okay.
Okay.
Because some people they don't know. I mean, they don't have any experience, right?
Okay.
So then I have to teach everything lah. Okay. Then because some parts is you cannot teach for the the beginner level. They don't have any experience, right? Because they don't know when is the system fault, what is the system fault, everything.
Understood.
So when you have experience, like later on, when you can share with me what experience you have, like fault or something, right? You can share to me. Okay. All right. Then Okay, this. Okay. So for PLC, before we go into the programming, everything, right? Okay. We need to understand the computer numbering. Okay, the computer numbering. Okay.
Okay.
Why the computer numbering is important? Because all the PLCs, right? All the PLCs is using computer number because you know PLC is a computer.
Yeah, understood.
Yeah, so it must use a computer numbering. So like decimal, hexadecimal, octal, binary. Okay. So maybe decimal, hexadecimal, all you learned before, right?
Yeah.
Okay. Maybe octal, maybe is new for you lah.
Yeah,
Okay.
maybe.
Yeah. Okay. So go through first. Okay. Like decimal, the number we use every day lah. Okay. So because decimal is 10, okay, the number we use every day, that is 0 to 9, then continue lah, 10 to 19, 20 to 29. Okay.
Okay.
Then we have hexadecimal. Okay, so hexadecimal mostly used in computers, PLC, and any other digital devices.
Okay.
Okay, so hexa means is 16. Okay, so the number will be from 0 to 9, then continue to A to F. Okay, I have
Okay.
16 digits.
Okay.
Then only continue with 10 to 19, 1A to 1F.
Okay, understood.
Okay, something like that.
Yeah.
Okay. Then we have binary. Okay, binary, you know that is the number is 0 or 1 lah.
Yeah.
Yeah. Okay. Like our digital input, digital output, all is in binary. Right? It's either 1 or 0.
Okay.
Okay. Then we have octal. Okay. Octal is normally used in early PLCs lah. Okay, early PLCs. Octal is 8 digit. Okay, is 0 to 7. Then continue with 10 to 17. Okay, okay. So octal for Siemens is a bit important lah.
Okay.
Okay, okay. Why is important later you can see. Okay.
Okay.
So this is example of in a table lah. Okay, I put in table. You can see like hexadecimal I have 0 to 0 to 9, then continue with A to F, right? Okay, I have 16 digits. Then if octal, you can see I have 0 to 7, 8 digit, and 10 to 17.
Okay.
Okay, then in binary, this is the value in binary. Okay, because
Okay.
it's base 2, right?
Yep.
Okay, so this one, all of these, you can use, you know, your computer calculator. Okay, anytime you want to change the values, right, you can use your computer calculator.
Okay. Okay.
Okay, so normally it will be standard like
Yeah.
this. Okay, so you can change to programmer calculator. So anytime you want to change the values from hexa or decimal, right, you can change. Okay, so like this, if I put 17 or in hexa is 11, all this. For when you do basic programming, you don't need that. You don't need this programming lah.
Okay.
I mean, okay. But when you do like intermediate, advanced programming, then you need this, because normally if you want to do analog programming, or any motor programming, right? Okay, if you open the manual will be in hexadecimal.
Understood.
Okay,
Okay.
so you can use this calculator to convert to decimal, because decimal is easier to understand, right?
Yeah.
Yeah. Okay.
Okay.
Right. Next, okay. This one is how to use the calculator.
Okay. No worries.
Okay. Then we go for the addressing.
Okay.
Okay. So I think you have seen before the address, Siemens address, right?
Mhm.
Like input is I, all that. Okay.
Okay.
So Siemens addressing using Octal method. That's why just now I say Octal is important for Siemens. Okay.
Okay.
Because you can see here is the first input is input 0.0 until 0.7.
Okay.
So it's using Octal. Then
Okay.
it become 1 byte.
Okay.
Okay, it become 1 byte. Then when 2 byte, because this one is I have 8 right? So we call 8 bit. Okay,
Okay.
1 byte is equal to 8 bit. Then when 2 byte together, it become 1 word. Okay.
Okay.
So all this later we will be doing lah. Okay,
Alright.
for I think for today maybe we'll be doing only the beat lah.
Okay.
Okay, see the beat everything. Then maybe tomorrow onward we will start using word, double word, all
Double
that.
word. Okay.
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 Then we can come back here and see back. Okay.
Okay.
All right. Then for output we using Q.
Okay. Yeah.
Okay, we know right. So
Yeah.
input is I, output is Q. Then for memory we use M.
Okay.
Okay. So example, because you see just now like inputs, like we can connect, right? We can connect sensors, switches, all that. Okay.
Yes.
For output we can connect relay, contactor, lamp, all that. Okay, but memory is inside the PLC.
It is stored in the RAM, is it?
Yeah.
Okay. Okay.
Okay, so it's inside the process, so it's for the process, or you can use for the HMI, all that.
Okay. Understood.
Okay, and same goes for data block. Okay, so data block also same like memory, similar, but in a bit different. In the way is the it as a block by block. You can arrange your um like memories, because data block is inside only inside the PLC, same like memory lah. Okay,
Okay.
so later we will see what is the difference when we are using the data block.
Okay.
Okay, all right. Then okay, this one all later we will see. Okay, later we will see. Okay, so until here I think the data block also no need lah, later we will see. Okay, until the memory, any question
So far no.
so far? No. Okay, so okay, what I do. Okay, so I open a Simatic Manager. So the first thing what I'm going to do is upload lah.
Okay.
Okay, so you know how to upload, right?
Yeah.
Okay, so I will do first. Okay, example. Okay, create a new project. I name it as a upload A1. into your folder. Okay, so when we want to upload, we need to configure the communication.
Okay.
Right, so communication, we have to go to set PGPC interface.
Yeah.
Okay. So I'm using a PC adapter, right?
Okay.
So first I will scan what is my setting. Okay, because you see here my CPU, right? Okay, this CPU, because the first port I can configure as a MPI and also as a DP Profibus.
Okay.
So first what I do, I scan, so I get a MPI.
Okay.
Okay, so what I can do, I can leave it auto or I can select MPI.
Okay.
Okay, so first we leave it auto. I click OK. So it shows the changes in the path. Then I go to PLC, upload station to PG. View. Okay.
Oh, we don't have to set the rack and slot, huh?
What is it?
We don't have to set the rack and slot.
No, because I have only one
Oh
one
yeah. Okay.
uh, one system, right?
Okay. Okay. Understood.
Then I don't need. If I have multiple, then I have to set the rack and slot.
Okay.
Because now is rack 0, slot 0,
Slot
right?
0.
Yeah. Okay. So I already uploaded PLC. Okay. The hardware configuration is here.
Yeah. Okay.
Okay. So here I have a CPU, a DIDO card, AIAO card. Okay. So this one, the one I upload, right? Okay. This one, why I get these modules, because earlier I downloaded these modules inside.
Okay.
So it
So it's
will,
still instead.
yes. So
Okay.
whatever I download, only that I can upload.
Okay.
Okay, right. Then later on the hardware side, later we come back lah.
Okay.
Okay. Okay. Then the S7 program. Okay, inside the S7 program, I will add the blocks and symbols, right?
Okay.
Okay. If you open the symbol, you see it's empty symbol. Empty. So you see, because Siemens, for Simatic Manager, when you upload, you don't get any symbol.
Oh, okay.
Okay, it will be empty.
All right.
Okay, then I go to the block. Okay, the block, you see, I have a lot of blocks inside.
Okay.
Okay, it means all this block is inside the CPU.
Okay.
Okay, then I open the OB1. Okay, the OB1 is the main, right?
Yeah.
Okay, so when I open, you see, after I upload, when I open, it shows a message that there are no parameter and local variable names.
Okay.
Okay, and the open block does not contain any symbol. Okay, you see, inside I have very simple program.
Okay.
Okay, so you can see there's no symbol name for this.
Mhm.
Okay, like we
Okay.
don't know what is this button, what is this output.
Mhm.
Okay, so this is what happened when you upload Simatic Manager, using Simatic Manager for S7-300 and 400.
Okay.
Okay. Then you can see I have OB1, but here I have other FC, FB, alright?
Yeah.
Okay. So it means the latest program I download only the OB1. This one all is already inside. Okay,
Inside.
inside the CPU. Okay. Okay, but about this later I will explain.
Okay.
Okay, means example lah, because we done so many trainings, right? So all the participants, they use this, they download. So whenever I download a new program, it will overwrite. Okay, it will, let's say I create a new project using OB1, it will overwrite only the OB1. The rest will be inside here only.
I see.
Okay, it's always inside. But if you, example, if you upload a company program, a company machine is different, because normally company machine is already programmed once, correct or not?
Yeah, correct.
So when you upload means all is related lah. All is related. For this particular, this CPU is we use for training. So this one all is the participants maybe do some programming. Okay, you see I open the FC, I have FB function block, I have a program inside. Okay, but you can see there's no name. This name is by default. Okay, maybe the previous participant, maybe they give a different name here. Okay, when you upload, you don't get the symbol. Okay. Alright. So this is, this how to upload, right? Uploading no problem, right?
No problem.
Okay, uploading no problem. Okay, then what we do, okay, I'll go back to the hardware. Okay, so I go back to the hardware. Okay, in the hardware I can go online and offline. Have you used this before?
Yes.
Okay, to get the status, right?
Yeah.
Okay. So we can get the status of this. You can see here I have a fault, right?
It's not connected, huh?
Yeah. It's not connect. Is what happened is the error here is because where is it? Okay, because I didn't connect the power supply here.
I see.
So that's why my PLC cannot detect.
Understood.
It shows the module not available. Okay, so it's very user friendly, because you see I can double click, it can show the message, everything. Okay, what is the status, everything. Okay, right. Then if the CPU have an error, okay, I can double click, I can go to the diagnostic buffer, I can see what is the fault. Have you used this before, diagnostic buffer?
Yeah, but I don't know like what to check and what not.
Okay, what to
I've
check,
seen this one.
what not lah. Okay, all this we will learn. Okay, so later we will create one fault, then we go to the diagnostic buffer, then I show you how to read the fault and what is the problem, all that. Okay, alright. It is about the hardware. Okay, so at the same time, another one I want to show you. At the same time, just now I upload, right? I upload using MPI cable, PC adapter.
Okay.
Okay. Then if we have a Profinet, okay. So like this, like this at the side here, you can see at the side here, I write the IP address lah.
Okay.
Okay. But let's say I don't know the IP address, right? Let's say I don't know the IP address. What we do that just now we use the MPI and upload.
Okay.
Okay, we go to the hardware. Okay, then we don't need to go online. Okay, we just double click the CPU. Okay, so this is the CPU. I go to the PNIO, the
Okay.
second port, because X1 is the MPI, X2 the
Yeah.
Profinet.
Right.
Okay,
But
so I done.
sorry. But
Yes.
we need to have the MPI cable lah to see the IP address, correct?
Yeah, we need to upload first.
Okay. Alright.
Need to upload first. Okay, after I upload, I go to the Profinet, then I can get the Ethernet address.
Alright.
Okay.
Okay.
Alright. Then from there, it's easier to communicate.
Okay.
Alright. Okay. So you want to try the upload?
From the Profinet, is it?
No, from the Profibus.
Okay, sure.
Okay, so you can. What I do, I close this one. Okay. You request control.
One moment. Okay, I request control.
Okay.
Okay.
Okay, you see, you can click or not. Go to create new project and upload.
I cannot click.
You can click. Yeah.
Oh, but
Wait.
can.
And okay, again. You try, cannot. You can click. Okay, wait.
Cannot.
Yeah. Okay, because yours is using as a guest.
Okay.
Because you
So
are not a guest, I already add you in my meeting list. Okay, wait. Okay. Okay. You share your screen. I see whether I can. I can control your screen or not.
share my screen.
Yep.
Okay, done.
Okay. I request control.
Okay.
Okay. I can control.
Okay.
Okay. So, but you can't control mine. Okay. Wait. I share again. Okay. I give control. Okay. Okay. Now try. You cannot open this one. Okay, you try this one.
Oh, this one can.
Or this one can. Okay. You try to click here.
Cannot.
Cannot. Why the Simatic Manager cannot? Okay, this one you try to click. Okay, this one can click.
Yeah.
Can open. Okay, but the Simatic. Okay, I will create a new project first. Okay, I name it upload to A1. Okay. Now you can try click the set PGPC interface.
Cannot.
Okay, wait. I think maybe it's in administrator. Okay, now you try to click.
Can.
Okay, now you cancel it. Just cancel it.
Yeah.
Cancel this one. Yeah. Upload day 2. Okay, there's this now. Okay, go to set PGPC. Yeah, now can. Okay.
Alright.
Why Devon just now cannot, huh?
No, because the Simatic Manager is in administrator. I open as an administrator, that's why.
Oh, okay.
Okay. Okay, you can leave it auto or you want to choose MPI also can.
I want to leave it auto lah.
Okay. Okay, next. Then need to upload, right?
Yeah.
Okay.
Okay.
Okay. All right. Then you open the block.
Okay.
Okay. So you get all the blocks lah.
Alright.
Okay. So this is how we upload the PLC program.
Okay.
Okay. So any question here?
So far no.
So far no, because you have done this, right? The
Yeah.
uploading.
Yep.
Okay. Okay. So now what we do? We create a new project.
Okay.
Okay. Create a new project. All right. Okay. The first thing is okay. I go to new. name it as day one.
By the way, this
As
Microsoft Teams is recording, right?
yeah,
Okay. So I can get the recording later on, right?
yeah, can.
Right. It's for my reference only.
Yeah, can.
All right, thank you.
Right. So browse. Okay, I save to your folder. So whatever I save to your folder later, I will share to you lah.
Okay, thank you.
Okay. So once I create a new project, okay. So first thing is I need to insert the station. Okay. So first is the Simatic 300 station. Okay.
Okay.
First we're going to add a Simatic 300. Then in the Simatic 300, can you see first I need to add the hardware, then only I get all the blocks, everything.
Okay.
Okay. So I go to the hardware. Okay. Then from the left hand side, okay, here is the catalog.
Okay.
Okay. Okay, let's say I already by mistake I close this one, right? So what I can do, I can go to view catalog.
Okay.
Okay. Right. Then I go to Simatic 300. So whatever I want to choose, I can choose from here. So the first thing for Simatic 300 is the rail.
Okay.
Okay, is the rail. The rail is the, the back plane.
Okay.
Right? This back plane. Okay, I have to choose the back plane first. Then from the back plane, I can choose all. Then I can put all the modules lah here. Okay. So the first thing I can put the power supply. No problem, because you see here. Here I'm not using a Siemens power supply. Okay. Okay, Siemens power supply means on this side, right?
Yeah.
Okay. I'm using a normal power supply lah. Okay. No problem. It can support. Okay. Even though I add here any power supply lah here. Okay. Any power supply you see. When I choose it shows here is okay. Here's the green, right?
Okay.
Means this power supply I only can add in number 1.
Oh, I see.
Okay, I cannot add anywhere. Can you see? You have selected the wrong slot for the power supply. So number 1 is for the power supply. Okay, let's say I add this, then I download to my PLC here, correct? And my PLC here, I don't have any power supply here. Okay, it's no problem because my PLC, this PLC, right, it won't scan the power supply.
Power supply. Okay, got it.
It only scan after the PLC, so the IO cards, the communication card only.
Okay, got it.
Okay?
As long as it has a power supply, then it's good.
Yes, good.
Okay.
Even though if I didn't configure here, example, if I didn't configure here also, no problem.
Okay, because it wouldn't read in the
Yes.
system.
Yes. So then it's no problem, so it won't give any system fault or anything.
Okay, got it.
Okay. So for training, then we just add one power supply. Okay. So we don't add the outdoor. Okay, why the outdoor power supply you don't need to add? Because later when I check the consistency, okay, it shows it won't not consistent, because outdoor power supply is for different PLC model.
Okay.
Because in the PLC, I have many PLCs here, you can see.
Sorry, but the consistency check is for what?
Consistency check means, let's say I selected a CPU, okay? Then I select the power supply, then I select all the IO cards, right?
Okay.
Okay, if the IO cards or power supply is
Not compatible.
not suitable or not compatible for the CPU, it will show error.
I see. Okay.
Okay.
Got it.
Yes. Next is the CPU. So the CPU we have here is here can see it's not clear, but I open this picture here. Okay. CPU 315 2PNDP.
Okay.
Okay. So what I do, I go to the then I close the power supply. I go to the CPU. Okay. CPU 315 2PNDP. The 2 means the 2 communication port. Okay. The 2 represent the number 2 is for the number of communication port, and it shows PN and DP, right? So
Profinet
PN is
Profibus.
Profinet and the Profibus.
Yeah.
Okay. So 315 PNDP. Then inside the 315, I have 3 modules. Okay. 3 different types. So the one we have here is a 2EH13. Okay, so you know where to see the part number, right?
Yeah.
Okay. At the side here, you can see the part number lah.
Okay.
Okay, but this part number is for this module.
Okay.
Okay. So if you want to see the part number, you need to take this type.
Okay.
Okay. So the part number is what? 2EH13. Okay. So I go for 2EH13. Then I have different address. I mean the version. Okay. So for the version, actually you can see here. Sorry. I can see here what is the difference between the version. Okay.
Okay.
Right. So this is the firmware. Okay. 2.3. Okay. 2.5. Okay, because 2.3 you see, it shows Profinet IO, Profinet CBA, the proxy, all that. But 2.5 it shows Profinet IO and IF1 extra. Supports RT. Right? Okay, supports RT means supports the runtime, the WinCC.
I see. Okay.
So if I select 2.3, then I cannot communicate.
Oh, you cannot communicate with the WinCC.
Yes.
Okay.
Then 2.5 and 2.6, I think is same lah. I think not much different. 2.5 and 2.6. Okay. All right. Then, and my module here also actually is a 2.6. You can see here. You can see 2.6.
I see. Okay.
Okay. All right. So I select the 2.6 and add here. So when I add CPU, okay, so it asks me whether I want to do any networking or not. Networking means the master and slave. Okay, if I want to add any modules or anything, okay, later we will see what is this. okay, the Ethernet interface.
Okay.
Okay, and by default it will give this IP address and this subnet mask. Okay, so
Okay.
what I do, I'm not going to add any network here yet. I click OK. Okay, so if I double click the MPI DP, okay, I can select if I want to change the port to MPI or Profibus. I can do. If I click Profibus, it seems like just now the IP address, the Ethernet, right? It asks us to do a interface.
Okay.
Okay, so I leave it as a MPI first. Okay, and this is my MPI address. Okay, no network, nothing. Okay, I click OK. Okay, slot number 3. Okay, slot number 3 is for the interface module. Okay, interface module. Interface module is I can use only these two. Okay, then others I cannot use. Then this one I can use lah. Okay, this one is the, you can see here, interface module for connecting expansion rack.
Okay. Like you want to expand to the ET200, things like that, right?
Yes. Same like ET200, right?
Okay.
Because ET200, if you see, it shows IM. So this slot number 3 is only for the interface module. For this interface module is for central rack. I only can use these interface modules.
Okay.
The ET200 also is an interface module, right?
Yes.
But I cannot use that because that must be outside. Together with the CPU inside the rack, I only can use this.
This IM.
Yes, these IM modules. Okay.
I see. Okay.
Then we don't have one module, so we don't add. Okay. Then for the input and the output card is from the SM. Okay, from the SM. So the first card we have here is DIDO, 8DI, 8DO. Okay. So what we do, we go into the DIDO and you can see the part number here. Okay. So the part number is 1BH01. Right. So I go back, I select this one. Okay. 1BH01 lah, this part number. Okay. Then you can see number 3 I cannot add. Start from number 4 until 11, I can add the IO. Okay. If you see, if I bring here, cannot. The module can be inserted only in slot 4 to 11.
Okay.
So I add here. Okay, when I add here, so here I get the address, the input address and the output address. Okay. So the input, because I have 8 input, so this number here is represent your byte number. This number.
Sorry, come again.
This number here, right? The byte number here. This address. Okay. This address, this address 0, the number here lah, the number 0. Okay. This one represent the byte number. 0. Means, okay. So
understood.
Here is 8 input, right? 8 input,
Yes.
8 output. So means for input is I0.0 until I0.7. For output is output is Q0.0 until Q0.7.
Okay, understood.
Let's say, for example, I add the 16 DIDO. Okay, example lah. I just add here. Okay. For 16 DIDO, can you see it shows 4 dot 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 5?
Yeah.
Means it's using byte 4 and byte 5. Because it's 16, right?
Yeah.
So it's using byte 4 until 5. Okay. If I add a 32 input, I just add a 32 input. Okay. It shows 8 until 11.
Got it.
Okay, so it meaning 8, 9, 10, 11 lah,
Yeah.
4 byte.
Yeah.
Okay, alright. So this one we are not using, so I just delete. I just show only lah.
Okay.
Delete. Okay, this one also I delete. Okay. Then the next card I have here is what? Is a 4AI 4AO.
Okay.
Okay. So what I do, I go to the AIAO, 4AI 4AO, and the part number is 3357GH00.
Okay.
So I look for that. Okay, 3357GH00. Okay. So I just take and add here. Okay. So this one also have the address lah. Okay. For analog address, later we will see.
Okay.
Okay, later we will see. Why this number here, why this number here, everything. Okay.
Okay.
Right. Okay. So once I done, what I do, I check the consistency. Okay. So it will show no error, means these IO modules can support this CPU.
Okay.
Okay. Then next, what I need to do, you need to do the save and compile. Okay. This is very important. Why? Okay. Wait, I'll show you. Okay. Okay. I do until here. I save first lah. I don't do compile. I just save first.
Okay.
Okay, wait. Okay. Let's say after I save. Okay, after I save, I get all this. Okay.
Okay. You mean nothing,
Okay.
is it?
What's that?
There's nothing on the blocks.
No. Yeah, of course lah.
Okay.
There is a block.
Okay.
OB1. Okay.
Yeah.
Okay.
Okay.
But you need to do the save and compile. Why save and compile? Because then only I get the system data.
I see.
Okay, actually, what is system data? System data actually your configuration. This is your system data.
I see. Okay.
Okay, this is your system data. So always remember when we are doing a new project, that is save and compile.
Okay.
Or let's say this program is already, this project is already there. Then your engineer or your company asks you to add another module, right? Okay. Example, you add a module or you replace this module to another one. You need to save and compile.
All right.
Okay. So then only. So after I save and compile, then only I will create all these, the CPU, the blocks, and the system data, and the OB1 by default.
Okay. Because
yes.
Yeah, the OB1 is by default because of the CPU, right? Like
Because of the
whenever
CPU.
there's a CPU, there's already OB1 for the programming.
Yes.
Okay.
So organization block, because this is the main.
Okay.
So now once I done the configuration, next what I do, I check my communication is a PC adapter, right? Okay. So if the communication is okay, I go here, then I go and download the module. Okay, I can click here or I can click this one also can.
Okay.
Okay, I load. So this one is just loading the configuration. Okay,
Okay.
load. Okay, so because this is my target here, then I view. Accessible nodes again. Okay, so it will download. Okay, so when download, it show the following module will be stopped for loading system data. Can you see the name system data?
Yeah.
Yeah. So now my PLC is run.
Mhm.
So when I click OK here, the PLC will go to stop mode.
Okay, understood.
Okay. So we must be very careful when we doing this system data lah, when we downloading the hardware configuration.
Okay.
Because you see the PLC can go to stop mode, right?
Yeah.
So if the PLC go to stop mode means it will off all my outputs.
Yeah. All the equipments will be down.
Yes.
All right.
Okay,
Got it.
so yeah, done before. Okay. Then after I finish, then do you want to complete restart? Yes. So if we start to restart, if there's no error in the system, I mean no problem, then I don't have any fault lah. If here in the slot number 6 I have one card, but here physically I don't have, then I will create a fault.
Okay.
Okay. Any question until here? The configuration?
So far, no.
So far, no.
Yeah.
Okay. So what we do, we go for a short break.
Okay.
A 10 minutes break like that.
All
You
right.
want to make a coffee or tea, you can make. Then we continue. Then we continue our lesson lah.
Okay.
Okay.
All right.
All right.